Hey everyone, I'm Justin, and this is my review of problem 11 in WebWork 15. It's an integral differential equation, which means there's a dependent variable y inside an integral while its derivative dy dt also appears. The first part of the problem asks us to find the Laplace transform of the solution using convolution. The second part asks us to find the solution. I already changed the notation of dy dt to y prime since we're used to that for these types of problems. So we have the initial condition, y of 0 equals 0. Next, we have to find the Laplace transform of each of these terms. So, Laplace transform of y prime. Plus, for the middle term, we use the convolution theorem. 25 times the Laplace transform of y of t times the Laplace transform of e to the negative 10t equals Laplace transform of 2. Finding the taking the Laplace transform, we get s times capital Y of s minus y of 0 plus 25 capital Y of s times 1 over s plus 10 equals 2 over s. Now we have to get the coefficients, group the coefficients of capital Y of s together. Capital Y of s times s plus 25 over s plus 10 equals, so it's going to equal 2 of s because y of 0 is 0 based on our initial condition. So now capital Y of s equals 2 over s times s plus 25 over s plus 10. We could leave it at that, or we could try to simplify it. So let's go down here. So y of s equals 2 over s over s plus 25 over s plus 10. Multiply the top and bottom by s. We get 2 over s times s plus 25 over s plus 10. Let's factor in the s on the denominator to get, let's write the denominator first, s squared plus 25s over s plus 10, 2. So now we can try to find the common denominator in the denominator to make it look better. Equals, so we know it's going to be s plus 10, so we multiply the numerator by s plus 10. So s squared times s plus 10 plus 25 over s plus 10, 2 over all of that. So again, multiply the numerator and then the denominator by s plus 10. We get 2 times s plus 10 over s squared plus, s squared times s plus 10 plus 25. Might as well factor in the s squared to get s times 2 times s plus 10 over s cubed plus 10s squared plus 25. This had an s plus 25s. Now factor out an s, and we'll get our answer for capital Y of s. It's going to equal 2 over s plus 10, 2 times s plus 10 over s times s squared plus 10s plus 25. But actually, we can simplify this even more. So capital Y of s equals 2 times s plus 10 over s times s plus 5 squared. In order to find the solution y of t, we need to take the inverse Laplace transform of both sides. So the inverse Laplace transform of capital Y of s equals the inverse Laplace transform of 2 times s plus 10 over s times s plus 5 squared. So we get y of t equals the inverse Laplace transform of 2 times s plus 10 over s times s plus 5 squared. Now, in order to find the inverse Laplace transform of this term here, we have to use partial fraction decomposition. So let's do that down below. So we have the term 2 times s plus 10 over s times s plus 5 squared equals, we're going to have something over s plus something over s plus 5 plus something over s plus 5 squared. For this problem, just simple a, b, and c. So we have to find the common denominator, which in this case is obviously going to be that at the bottom there. So multiply the entire thing by s times s plus 5 squared. And that gives us 2 times s plus 10 equals a times, the s's are going to cancel, so s plus 5 squared plus b times s plus 5 plus c times s. So one way to figure out the coefficients is to set s equal to certain numbers that will cancel out two of the terms. So let's say let s equal 0. So when we do that, we can clearly see that c is going to be 0 and b is going to be 0. So let's plug s equals 0 into the left and right side. So 2 times 0 plus 10, 2 times 10 is 20, equals a times 0 plus 5 is 5 squared is 25, equals 25a. Thus, a is going to equal 4 over 5. Circle that because we'll need that soon. Now let's let s equal -5. So doing that, on the left side, we get -5 plus 10 is +5, times 2 is 10, equals -5 plus 5 is 0, so a cancels, -5 plus 5 is 0, so b cancels, and then c, we get -5c. You can see that c is going to equal -2. So unfortunately, we can't set s equal to anything to find what b is, so just have to do good old-fashioned substitution. So let's first rewrite this entire thing here. So we get 2s plus 20 equals a times s squared plus 10s plus 25 plus bs squared plus 5bs plus cs. Let's factor in the a, rewrite all this. 2s plus 20 equals as squared plus 10as plus 25 plus bs squared plus bs plus cs. Now we know what a and b equal, so we can plug those values in, and we get 2s plus 20 equals 4/5 s squared, plus, so 10 times 4/5, 10 divided by 5 is 2, so 2 times 4 is 8 s plus 25 plus bs squared plus 5bs so not 25, sorry about that. So a is 4/5 times 25, so 25 divided by 5 is 5, times 4 is 20, plus 20, plus bs squared, plus 5bs, plus, so plus, no, minus, because c is -2, minus 2s. Combine the like terms, we get 2s plus 20 equals, and let's just combine the coefficients for each of the variables. So 4/5, so for s squared we have b 4/5 and b 4/5 plus b s squared. So we have 8s minus 2s, so that's going to be 6s, and then the terms for s plus 6s plus 5b times s plus 20. So there are a couple ways to figure out b. Easiest might be, since there's no s squared on the left side, we know that 4/5 plus b is going to equal 0. Thus, b is going to equal -4/5. Could do the same thing with the s term. Seeing the coefficient is 6s plus, oops, not 6s, 6 plus 5b equals 2. But this way might be a little easier. So yeah, by partial fraction decomposition, we find that y of t equals the inverse Laplace transform of, plugging in, a is 4/5, 4/5s, b is -4/5, minus 4/5s plus 5, minus 2/s plus 5 squared. Okay, so time to find the inverse Laplace transform of each term. So y of t equals 4/5 times the inverse Laplace transform of 1/s. Minus 4/5 inverse Laplace transform of 1/s plus 5 minus 2 inverse Laplace transform of 1/s plus 5 squared. Okay. So we could start y of t equals inverse Laplace transform of 1/s is 1. So y of t equals 4/5 minus, so the inverse Laplace transform, or 1/s plus 5, is going to be e to the negative, so a is going to be -5. So we get minus 4/5 e to the -5t. Now for this last term, we have to apply the inverse form of the first translation theorem. So over there, that is The rule is inverse Laplace transform of capital F s minus a is going to equal inverse Laplace transform of capital F of s minus a, which is going to equal e to the at f of t. So in our case, we get that -2 times the inverse Laplace transform of 1 over s squared s to s minus s plus 5 is going to equal -2t, because 1 over s squared, inverse Laplace transform of that is t, -2t e to -5t. So then we just plug that in down here, -2t e to -5t. And that's it. We get our solution of the problem, y of t. That's the answer of part B.